Hello everyone. Today we will see some application of divisibility rules. So here is the first question. It says that if 2482A6 is divisible by 4 and 3, what are the possible values of A? So the given number is 2, 4, 8, 2, A and 6. Now we know that for a number to be divisible by 4, the last two digits must be divisible by 4, right? So we can take A6. This should be divisible by 4. Now what are the possible values for which the value of A, this number will be divisible? So let's take the possible values of A as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. 10 cannot be a possible value because that is not a single digit number. It becomes double digit. So the possible values can be 0 to 9. Now substitute A with 0. So it is 6 by 4. So it is not completely divisible, hence 0 is ruled out. 1. Yes, 16 is completely divisible by 4, hence 1 is a possible value. 2. So 26 is not completely divisible by 4, hence 2 is ruled out. 3. 3 is a possibility. 3 because 36 is completely divisible by 4, hence 3. Now 46 is not divisible, hence 4 is ruled out. Now 56 is completely divisible by 4, hence 5. We can see here a pattern, okay? So every alternate number is divisible by, when we substitute the value of A, it is divisible by 4. So 6 is ruled out, 7 is a possibility, 8 is ruled out, 9 is a possibility. So we get a set of possible values that are 1, 3, 5, 7 and 9. Now it also says that the given number is divisible by 3. That means 2 plus 4 plus 8 plus 2 plus A plus 6 is divisible by 3. So if we add all these numbers, we get 22 plus A, which is divisible by 3. Now let's substitute the possible values of A here and see which all values are completely divisible by 3. Now substituting A with 1, we get 23. It is not divisible by 3. So 1 is ruled out. Now 3. So 22 plus 3 is 25, which is not completely divisible by 3. Hence 3 is ruled out. Now we put the value of A as 5. 22 plus 5 is 27, which is completely divisible by 3. Hence 5 is one value. Now substitute A with 7. 22 plus 7 is 29, which is not completely divisible by 3. Hence 7 is ruled out. Now we put a value of A as 9. 22 plus 9 is 31, which is not completely divisible by 3. Hence 9 is also ruled out. Hence the possible value of A is only one number, that is 5. So here the question asked was, what are the possible values of A? So the answer is A equals 5. But they can also ask how many possible values of A are possible. In this case, we have only one possible value. In that case, the answer will be 1. Okay. Now let us look at the second question. It says that if the number 18601x57y is divisible by 72, find the value of x plus y. Now the given number is 18601x57y and is divisible by 72. Now we know that 72 is a composite number. right? Which can be written as 9 into 8. So these are co-prime number, right? 9 and 8 are co-prime. So it is written in that form. So let's see first. For 8, we know that the last 3 digit must be divisible by 8. Then the complete number is divisible by 8. So we can say that 57y must be divisible by 8. So 8 7 is 56. We get remainder 1. So we can say that 1y. We can write it like this also. 1y by 8 should 1y should be completely divisible by 8. Now let us see what all possible values y can have that makes it completely divisible by 8. So let's start with 0. Can y have 0? So making it 0 will make it 10, which is not divisible by 8. Hence 0 is ruled out, 1 is ruled out, 2 is ruled out, 3 makes it 13 is ruled out, 4 makes it 14 is ruled out, 5 is ruled out, 6, yes, 6 is a possible value. Now 7, 8, 9 are ruled out. Why? Because if 6 is one possible value which makes it 16, the next value will be 24. So in that case 6 plus 8 will be 14. Okay, so next value here will be 10, 11, 12, 13, 14. So 10 is ruled out, 11 is ruled out, 12 is ruled out, and 14 will be the next possible value. But y is a single digit while 14 is a double digit. So this is already ruled out. So from here we got only one possible value of y, which is equals to 6. Now we have broken down it into 9 into 8. So we will see for 9. So we know the divisibility rule of 9. The sum of the numbers must be divisible by 9. This number should be divisible by 9. So we can write it like 28 plus x plus y should be divisible by 9. Now substitute y with the value. So we get 34 plus x, which should be completely divisible by 9. So this also we can write 3 plus 4, that is 7. 7 plus x should be completely divisible by 9. Now let us see what all possible values can x take. So we can start with 0. Putting 0 will make it 7 by 9, so it is ruled out. 1 will make it 8 by 9, so 1 is also ruled out. Putting 2 will make it 9. 9 by 9 is divisible, completely divisible, so one of the value is 2. Now next value will be 2 plus 9, 11, which will fulfill the criteria, but x is a single digit. So double digits are already ruled out, and any further single digit is also ruled out. So the value of x is 2. Now in the question, it is asked find the value of x plus y. So we know that x is 2 and y is 6. So x plus y equals to 2 plus 6, which is equals to 8. So the answer is 8. Now let us see another question. The number 94220P31Q is divisible by 88. What is the value of P plus Q? So we know that 88 is a composite number which can be written as 11 into 8, and 11 and 8 are co-prime. Now we will see the divisibility rule by 11. So we know the divisibility rule of 11. The difference between sum of numbers at the odd places when counted from right minus or and sum of digits at the even places when counted from right. So we will count it first here. So sum of this is 9 plus 2 11 plus 3 14 q, right? So we can write it 14 plus q minus sum of digits at the even places when counted from right. So we get 4 plus 2 6 p and 7. So we can write it as p plus 7. So this should be divisible by 11. Solving this, we get q minus p plus 7. Now we know that this is completely divisible by 11, right? So what are now q minus p plus 7? What are the possible values that it can have? So we will keep it aside for now and we will see the divisibility rule of 8. Okay, so let's write by 8. We know that if the last 3 digit is divisible by 8, the complete number is divisible by 8. So the last 3 digit is 31q. So let's take 31q. If this is divisible by 8, the complete number is divisible by 8. So 8 3 is 24. The remainder is 7. So if we can also write it as 7q. Now this 7q should be divisible by 8. Now let us find the possible values of q. So if we put 0, this will make it 70. Is 70 divisible by 8? No. So 0 is ruled out. Let's put 1. It will make it odd number. It is already ruled out. Let's put it 2. Yeah, 2 is completely divisible. I mean, if we put 2, the value will become 72, which is completely divisible by 8. Hence 2 is a possible value. Now 3, 4, 5, everything is ruled out. Why? Because the next multiple of 8 will come at 10. But 10 is a double digit number, which is ruled out because q is a single digit. Hence the only value that is possible for q is 2. Now we got the value of 2. We can substitute it here. So 2 minus p plus 7. This should be divisible by 11, right? Now we can also write it. So for it to be divisible by 11, either this should be equals to 0 or should be multiple of 11. So the possible values are 0, 11, 22 and so on. Now let's see. If we put 2 minus p plus 7 equals 0, p equals 9, which is a possible value. Now let us put another value 11. So 2 minus p plus 7 equals 11. If we take p this side and bring 11 this side, we get 9 minus 11 equals p. Now the value of p is minus 2, which is not possible. Hence this is 11 is ruled out. Similarly, now For any value greater than 0, we will always get a negative number. So all the values greater than 0 are ruled out. So when we put the value of this equation as 0, the only value of p that we get is 9. Now the question asked it, what is the value of p plus q? So we know that p equals 9 and q equals 2. So the answer is 9 plus 2, 11. Okay, let us see one more question. 49A 81B is divisible by 66. How many pairs of A, B are possible? Here the number of pairs of AB that are possible is asked. So let's see. So it says that the number is divisible by 66, and 66 is a composite number which we can write in co-prime form as 11 into 6. Now 6 is again a composite number, and we know the divisibility rule of 6 is if the number is divisible by both 3 and 2, that means the number is divisible by 6. So we can write this as if the number is divisible by 11, 3 and 2, then the complete number is divisible by 66. Here we broke down 6 into 3 into 2. So the number must fulfill all the three criteria. Should be divisible by 11, should be divisible by 3 and should be divisible by 2 for the number to be divisible by 66. And we know that the number is divisible by 66. Now we see one of the criteria is the given number should be divisible by 2, and for it to be divisible by 2 it needs to be a even number. So b can take an even value, so we can say that b is even, possible values being 0, 2, 4, 6 and 8. Now let's try for 3. For 3 we know that to be divisible by 3 the sum of the numbers should be divisible by 3. Okay, let's add this. We get 22 plus a plus b. Now this should be completely divisible by 3. Okay, now assume a plus b, the value of a plus b. What are the possibilities? If a plus b is 0, it is 22 by 3, which is not divisible, completely divisible, hence 0 is ruled out. So a plus b cannot be 0, right? So 0 is ruled out. A plus b, can it be 1? No. Why? Because 22 plus 1 is 23, which is not completely divisible by 3, hence 1 is also ruled out. Now can a plus b equals to 2? Yes, 22 plus 2 is 24, which is completely divisible by 3, hence a plus b can be 2. So we can write a plus b equals 2. Now since we are dividing the number by 3, we know that all the successive third number from 2 will be divisible by 3. So we can say now a plus b equals 5, a plus b equals 8, a plus b equals 11, a plus b equals 14, a plus b equals 17, a plus b equals 20. Now let's see, is this possible? It is not possible because two single digit can never make a sum of 20. To make it a sum of 20, one of the digit has to be a double digit. But we know that both the digits are single digit, hence this is ruled out. Okay. Now it we know that the given number is also divisible by 11. So let's find out for 11. And for 11, what we need to do is we need to take the difference of sum of the digits at odd places when counted from right with sum of the digits and sum of the digits at even places when counted from right. So let's add, let's take the sum of the digit. So we get 9 plus 8 plus b minus 4 plus a plus 1. Now we know that this should be completely divisible by 11. So 17 plus b must be completely divisible by minus 5 plus a must be completely divisible by 11. Now taking the bracket of, we get 12 minus b minus a. Sorry, 12 plus b minus a. So this value should be completely divisible by 11, right? Now to be completely divisible by 11, this value can take the possible values as 0 or multiples of 11 and so on. So let's see what happens when it takes the value as 0. So 12 plus b minus a equals 0, which makes b minus a equals minus 12. Removing this minus part makes it a minus b equals 12. Now two single digit can never make the difference 12. Hence a minus b 12 is ruled out. Now let us take again 12 plus b minus a equals 11. So b minus a equals minus 1. Removing minus, so it would be a minus b equals 1. So this is one possible value because two single digit can have a difference of 1. Let's take third. 12 plus b minus a equals 22. So b minus a equals 10. If you now b minus a, two single digit cannot have a difference of double digit. Hence this is also ruled out. Now if we put any value greater than 22 in the equation, we will always get two digit as the difference of the digits. Hence all the values greater than 22, I mean 11 are ruled out. So 22 is ruled out, 33 is ruled out. Similarly, all the values are ruled out. So now we have only one value, that is a minus b equals 1. Now if we do a plus b plus a minus b, it will be b and b will cancel out. It will be 2a, right? So we can say that a plus b equals to 2. The value of a plus b equals to 2. We add a minus b to this value. So we can do the value of A minus B is 1. So how we can write this? A plus B plus A minus B. A minus B is 1. So we can write it as, and we know that A plus B plus A minus B is 2A. So we can write it as 2A equals to 2 plus 1, which is equals to 3. This implies A equals to 1.5. Hence this is ruled out. Now let us put 2A equals 5 plus 1, which is equals to 6. Hence A equals to 3. Now if A is equals to 3, we can substitute the value here and we can get the value of B. So this implies B equals to 2. Now again let's put 2A equals 8 plus 1, that is 9, which makes A equals to 4.5, as this is ruled out, and this is a possible value here. Okay, now again 2A equals 11 plus 1, which is equal to 12, which implies A equals to 6. If A equal to 6 implies B equals to, we put a value of A is 6 here, B equals to 5. Now again this can be a possible value. Now 2A equals 14 plus 1, which is equal to 15, which implies A equals to 7.5, hence ruled out. Now again 2A equals 17 plus 1, which is equal to 18, which implies A equals to 9. Now if A is 9, implies B equals to 17 minus 9, that is 8. Now this is again a possible value. Now for this number to be completely divisible by 66, it has to fulfill all the three criteria. It should be divisible by 11, by 3 and by 2. Now to be and we know that B should be even. Now let's see here, B is equal to 2, which is even. Here B equals to 5, hence this is ruled out. Here B equals to 8, and this is a possible solution. So we have two possible solutions, okay, two pairs, where A and B equals to 9 and 8, and another pair is 3 and 2. The question asked is, how many pairs of A and B are possible? Answer is 2 pairs. And the pairs are 9 and 8 and 3 and 2. Thank you.